Hi everyone, this is Automatic Addison here. I am in the Alaskan wilderness. See beautiful, let's go around here. You can see beautiful snow mountains behind me. And as I was doing my hike today, I had an interesting thought. A lot of people ask me, how do I get started in robotics? And after you go through those introductory courses, what should you do next? And so in this video, I'm going to answer those questions. So a lot of university courses in robotics, they'll typically have you start with some fundamentals. So linear algebra, you'll take a course in calculus, and you'll do some introductory robotics course where you'll do a lot of work by hand, where you calculate inverse kinematics and forward kinematics by hand and do a lot of this. And this way is called the bottom-up methodology. This is the way that you'll typically learn robotics in university, which is where I'd say most people get their start in robotics. And this is just wrong. This is just a terrible way to teach robotics. I've always been against this. I understand why universities do it the way they do. They've got to fit everything into a nice, cute semester, and it's just easier to replicate a course that way because you can hand out assignments, you can hand out tests, and people can take these tests, and it's easier for the professor to grade. And a lot of these universities, the professors are not totally incentivized to teach very well. They're incentivized to do research. So I learned that way in school, and I really just think it's boring. I really don't think it's the way that you should be teaching robotics. A better way is what I call the top-down methodology, where you start with the problem that you want to solve, and you use robotics to solve that problem. And it's project-based learning. That's the way to learn robotics. Now, a lot of these courses, you'll have projects in there, but you'll have just an overload of theory. And it's very discouraging to the beginning roboticist, beginning robotics developer. So a better way is to do like this. You start out, get some fundamentals in Linux. So you definitely want to be good in Linux because the majority of robots are going to involve Linux in some way. That's an operating system. And so I would recommend starting out getting the fundamentals, taking a basic course. You can go on YouTube, you can go on Udemy, and just get the basics of Linux. Just understand the top commands, how to move yourself in and out of the terminal, how to navigate around the terminal, how to do certain things like start files and write a bash script, just the basics. And that should take about 2 to 3 weeks or so. And then once you've done that, then you want to go to Python. And again, just take a fundamental course where you can master the fundamentals of Python, because no matter what you are doing in robotics or even artificial intelligence, you're going to be touching Python in some form or fashion at some point. So you want to make sure that you really understand how to read Python code and how to write Python code. And that should take about 2 months or so. 2 months. Just get the fundamentals in Python. Then after you get good with Python, from there, go on to C++. And don't go beyond just the fundamentals or the basics. You don't need to know C++, all these esoteric, complicated data structures and libraries. You don't need to be an advanced C++ developer to build functional and very, very darn good robots. So take a fundamental course in C++. You can find some courses for $15 on Udemy. You can go on YouTube. There's lots of people teaching C++, the fundamentals. Learn C++ in an hour, that kind of thing. Get good with the fundamental of C++, how to create variables, how to write if statements, how to create basic programs, how to compile a program, how to run your program. Just the fundamentals. I'm going to say fundamentals all the time because in most fields of human endeavor, the way to move the needle is not to master some esoteric advanced concepts that not everybody agrees on. The way to move the needle is to master the fundamentals. And that goes for a lot of things, and whether it's in programming, in sports, in chess, in music. You want to be really, what separates the men from the boys is the men master the fundamentals, and they're very, very good in the basics. It's almost second nature to them. So that should take another 2 months. So here you take a couple weeks to learn Linux. You take a couple months to learn Python, and then take another couple months, 2 to 3 months to do C++. Right now we're up to month 5, and that's when you want to dive into ROS2. Just dive into it. Dive into the ROS2 fundamentals and the basics. And now you can go to the ROS2 website. They've got some tutorials there, and yeah, they're of varying quality, and that's how I got started. And it's a good way to start if you want to. They're totally free. I think a better way to do it is to take a ROS2 course, and you can find some on Udemy. You can find books that are on ROS2. They've got a lot of people that have ROS2 courses. I might even have one in the future that I provide here on YouTube for free. And you want to learn how to create a node. You want to learn about topics, how to create a publisher, how to create a subscriber node. You want to learn how to create a ROS2 action, a ROS2 service, how to work with ROS2 parameters, how to create a launch file. Those are the real fundamentals which you will use again and again throughout your robotics career. So master those fundamentals, and that can take about a month and a half or 2 months to really master the basics, the beginner parts of ROS2. Then from there, you want to quickly move on to ROS2 navigation. And I say to start with the ROS2 navigation stack before you go into manipulation robotics arms, just because I find it easier. And so Steve McKenzie has created some very, very good ROS2 navigation tutorials on the Nav2 website. Go through all of those. Look through the GitHub for Nav2. Make sure you know how to develop a mobile robot in simulation in Gazebo. Make it move from a starting location to a goal location. Make sure you can really get good. Get good with that, because it doesn't matter what kind of robot you will build. At some point, you're going to encounter a robot that needs to move from a starting location to a goal location. And the best way to do that is the ROS2 navigation stack. That's the de facto standard way to navigate a mobile robot in robotics today. It's the most widely used navigation stack, software stack for ROS2. So get good with that. Spend about a month or 2 on navigation, and then go to robotic arms. And the de facto standard, the standard software for that is called Move It 2. Move It 2. And that's where you want to go to the Move It 2 website, run through the entire tutorial. This is for ROS2, for a robotic arm. And I believe right now they are using the Frank Amica Panda arm. That's a cool arm. Make sure you can perform a basic pick and place task where you identify an object in a camera, identify its coordinates, you pick it up and then place it in another location. That's a really basic movement that you want to be able to do in simulation. And then from there, after you go spend a couple months on the manipulation, I would then get dirty with the hardware. And before getting dirty with the hardware, what I would do is think of a project that you would like to do. Maybe it's a project you've seen on YouTube, or maybe it's a particular problem you want to solve in robotics. And try to solve it using actual hardware. So get dirty with the robotics hardware. And so if you are doing the ROS2 navigation stack, you can find many mobile robots off the shelf. You can start with something off the shelf. Yaboom, I know they make the Yaboom car, which is a ROS2 based mobile robot. And when you're trying to make an actual physical robot move in the real world, you will encounter all sorts of problems. And through the problems, you will learn robotics. You must push through those problems. Robotics is all about obstacles and pushing through problems. Lots of stuff won't work. My robots never worked the first time I put the hardware together. And that's good. That's where you learn. That's where you learn. You go through those growing pains and those problems, and be sure to solve them. Don't give up. That's where you become a good roboticist, is to push through those obstacles. So get your hand on some hardware. So Yaboom Car is really good. It's low cost, mobile robot, and falling in the snow here. We get on some sturdier ground. And then for the robotic arm, there's a lot of companies that make robotic arms. There's only a few that make robotic arms that are actually affordable for a hobbyist or a student. I'd say under $1,000. There are Elephant Robotics. I know they may have their MyCobot series. They have a robot that you can use with Arduino and Raspberry Pi, as well as NVIDIA Jetson for $600. That's a good place to start. So make sure, though, that you can make these robots move in simulation first. I say simulation like Gazebo or the NVIDIA Isaac simulation, because you don't have to spend any money. So you can test all these algorithms in simulation free of charge. And that's a very, very good way to get started. If you just don't have a lot of money and you're low budget and you just want to get started really understanding how to write robotic software. But go to the hardware as well. Make sure you don't just stick in simulation, because going to the hardware is where you're really going to encounter a lot of the electrical issues that are very, very common in robotics. And well, I mean, robotics is about the physical world too. You know, it's about making things move and manipulating the external environment. So if you only stay in simulation, you're not going to be a good roboticist. So right now we're at month 7 or 8, and that's where you start to build actual physical robots. So, and then you may have built your first robotic arm, you built your first mobile robot, maybe you've taken one on the shelf, and you're bored now. What do you do next? Well, that's where you can take your robotic skills to the next level. And the way to do that, you've got 2 ways. You can think of a problem you want to solve and create a project for yourself, whether it's using a mobile robot or a robot manipulator, robotic arm, and build that robot from scratch. So think of a project and a problem you want to solve, and use robotics to solve it. Another good way, if you can't think of a problem, because sometimes I can't actually think of a problem I'd want to solve, or maybe the problem that you want to solve is too big for your budget or what you're able to solve right now. And what I would say is, go take a look at research papers. Take a look at research papers and replicate the results. And a good way to do that is go to Google and search for graduate level, advanced graduate courses in robotics. And there are a lot of good ones. You have Stanford, you have Berkeley, University of California, Berkeley. You have University of Washington. You have University of Southern California, UT Austin, I know. A lot of these big-time universities, Carnegie Mellon is one, big-time robotics universities. I love it because they put a lot of their graduate course syllabi and graduate course information freely available online. And these advanced graduate level courses, most of them are research paper based. And so they will list all of these very highly cited and very influential research papers. And it's like a gold mine. It's like a gold mine. And you can go there and use ChatGPT or Claude, whatever AI tool you like to use, and summarize these top research papers that you see cited again and again at advanced graduate level courses. And then pick one that's interesting to you. Pick one that's interesting to you and study it. Study it like you would study for a test. And then what you want to do is, after you study it, try to replicate the results that the author of that paper was able to produce. And by doing that, that is how you are going to take your robotic skills to the next level, because you're going to start to see gaps in the research and gaps in the market, better ways to solve certain problems. And you'll have so much to talk about, say in a job interview, and you'll start to build a really academic level and professional level, a portfolio that everybody will respect. And your skills are just going to get good. Your ability to read research papers, all of that technical jargon and break down the complex mathematics is going to set you apart from the pack. And you're going to start developing some really marketable skills, potential higher earning skills that you can carry with you. And never stop reading research papers and trying to replicate your results. I always, when I'm go traveling, or when even now I'm on vacation here in Alaska, I'm always keeping up to date on what the latest research in robotics is saying. And I always want to see, to be at the forefront, on the cutting edge. And to do that, you need to be able to not just read the papers, but you need to be able to actually replicate the results, be able to reproduce what the author actually produced. And that is where you're going to get good. So that's my advice. So start with the basics: Linux, Python, C++, basic ROS2, navigation, then manipulation, then get dirty with hardware for a month or two, and some off-the-shelf robotic arm or off-the-shelf mobile robot. Fool around with that for a little bit, and then start reading research papers and replicating the results. And I guarantee you, you are going to be the robotics developer, the roboticist that employers, as well as universities, if you're looking at perhaps going for a PhD, or you are wanting to be a professor somewhere, they're going to be salivating over you, because you'll be able to speak so eloquently about really deep problems in robotics, and you'll be able to solve a lot of the deepest problems in robotics, and be able to speak intelligently about research topics. And one other note I will say in terms of finding good research papers as well. The two prominent conferences are called ICRA. This year it's going to be in Atlanta, my hometown, in May, and IROS. Those are the two most, I'd say among the two most influential robotics conferences. Take a look at those as well. Go on their website. You can find some really good papers as well. And those are good sources that you can, not just after you learn robotics and you read a paper. This is something you can do throughout your career. And you can even go to the conference and meet the authors and listen to the talks. So that is my advice for how to get started in robotics, and then what to do beyond. That's it. It's getting dark now. I'm gonna head home. Automatic Addison here. Keep building. Thank you for watching.